Welcome to another video lesson on workshop processes. Today this is the second lesson on milling operations. In the first lesson of milling, we discussed milling machines, the milling machine capabilities, the parts of milling machines, the accessories of milling machine, and of course, we mentioned the safety requirement for milling machine. In this video, we'll be looking at some of the operations that a milling machine can perform. But before then, we need to look at the basic techniques by which milling operation actually works. Milling operation works on the techniques of peripheral milling, face milling, contour milling, and of course, we have pocket milling. In peripheral milling, it is possible for the cutter to move over the workpiece on a gradual basis while the work is being milled down to the level that is required for the job. And in the case of the face milling, the cutter is given the ability to rotate while the work is fed into the cutter and the surface of the work is being cut in that manner, so producing a flat surface at the end of the day. And of course, we equally have two major types of milling techniques too, the upcut milling and the downcut milling. Whichever case that is being used, at the end of the day, the material is going to be removed and the required surface to be generated is being achieved at the end of the day. In the case of plain milling or surface milling, we can see a situation whereby if a slab cutter or a face milling cutter with indexable insert is used to generate a flat profile on the job, like the case that is illustrated in my slide, the indexable edge of the cutter is rotating on the job, and the cost of rotating is producing the required flat surface on that particular job. Each of these edge of the cutter is the one that is doing the cutting, and that is the indexable insert. By the time this insert gets blunt, they can be removed. Another new set of inserts put in place. This type of tools can last longer because the holder will still retain, while it is possible because the inserts are replaceable. They are meant for heavy works. This is a typical example of a slab milling operation to get a face of the job flat, to get the face of the job produced flat. It's a type of milling operation, and it's very common if one requires to get a flat surface. Other type of milling operations that are available is what we call slitting. Slitting is a very simple operation. It's a process of slitting a particular metal or material into two, making use of the cutter that we call the slitting saw. The slitting saw is installed in the arbor of a horizontal milling machine while the work is fed into the rotating cutter. And in the process, the cutter slits the job into two. Slitting can be used to get some metal or material cut into pieces within a very short period of time, as the case that is illustrated in my slide. The graphical expression is a slitting process, whereby the cutter is revolving, a slitting saw is revolving, and the work is fed from the opposite direction against the direction of rotation of the cutter. And in the process, the job is slitted. And of course, slitting is similar to slotting. But in this case, slitting gets to the bottom of the workpiece, dividing the work into two. But slotting is creating a part that we call a slot. The process of slotting will not get to the bottom of the workpiece, but it is creating a groove. In some cases, it may be square, it may be another groove, a curved groove of another configuration. But like the case that is being illustrated in my slide is a rectangular slot provided for the passage of another member. But the technique is similar to that of slitting. The work rotates, the cutter rotates in the opposite direction to the direction of feed of the work. The table that is carrying the work will have to be fed opposite to the direction of rotation of the cutter. The two processes are similar, but I just mentioned the difference. The slotting process will not get the work slotted to the bottom of the workpiece, while it's going to stay somewhere around here. The slitting divides the work into two. Another milling operation is straddle milling. There are instances where we want to get two sides of a work milled to the same level. So one does not need to be doing it one by one. One can do it through the process of straddle milling, a process that requires one to install two cutters at a distance to each other, especially the distance that is exactly the gap of the surface that is allowed between the two cutters. The cutters will be rotating at the same speed since they are on the same arbor, and they will be doing the cutting at the same rate and at the same speed. This guarantees efficient milling of that particular work, and at the same time, it provides the opportunity for one not to repeat a task two times. That task that one could have done two times, one has the capability to do it in a single pass or the milling cutters on through the process of the straddle milling. Of course, another type of a milling process is the form milling. It is not every job that has a straight shape like that. One can have some shapes that have contours, that these contours cannot be easily cut with the regular cutters that we know. One may need to go for some special tools. We call them form cutters. So this special tool will create the curvature of the tool on the job, like the case we see in the second sketch in my slide. The B part of it, this curved orientation cannot be achieved with these straight cutters. It cannot be achieved with end mill, but it is possible through the use of these form cutters. This is equally mounted on a horizontal milling machine. This is the hub of the milling machine, and the cutter is mounted on it. The cutter is secured in position by the collars that are being mounted on the arbor of the milling machine. These are all the processes that are achievable on the horizontal milling machine. I have told you about slab milling, getting the surface of the work flat by revolving the cutter on the workpiece that is being fed into the machine. So, process of slab milling is very important to generate flat surfaces. And of course, one can begin to do some other operations on the vertical milling machine when it comes to making use of end mills. End mills, you can only accommodate them on the vertical milling machine when it is become necessary for one to get shapes like a slot, keyways, and some other grooves. One needs to machine or to mill them on some work pieces. One requires a vertical milling machine. And in this process, end mills are going to be used. Like the case that is being illustrated in my slide here, we have a situation whereby a T-slot is to be milled. This T-slot is to be milled. One cannot get it done making use of, there are other processes by which one can get this done, but it's going to take longer time. But here, with a single process of slotting, making use of a special drill, a special mill cutter that we call T-slot cutter, one can get this T-slot produced without any hassles. Likewise, one can make use of this particular cutter tool to create this part first, then before we make use of this T-slot cutter to get the lower slot done. This one will create the first cut, while this one creates the second cut. That is the process. We can get the first process done on the horizontal milling machine, making use of this cutter to create the first groove, while the second slot that will accommodate the both edge will be provided by the T-slot cutter. That makes the job very easy. So there are other considerations that one needs to take into consideration when one is working on the milling machine. We need to take into consideration the operating condition. What is going to be the feed? What is going to be the speed? Considering the type of material that one is to cut and the type of tool that one is to be used. So if one is to cut a low carbon material with an uncoated carbide tool, one will be considering some type of a particular type of a feed and speed as depicted in the table that is being shown in the slide. So, because it is not every speed that is so good for a particular type of job, the type of the material that is to be cut and the type of cutter that is to be used will actually determine what type of speed, what amount of feed that is to be given to the machine. So at any particular point in time when a particular job is, one need to consider all this and select the appropriate speed and feed that has been designed for that kind of job. And it is equally important for one to take note that most of these operations on the lathe, on the milling machine, they are operations that one can get familiar with. The more practice, the more you get familiar with the use of the machine. More practice leads to more experience. Other operations is the ability of that milling machine to get some special profile. It can get some special profile on a job. Contours. One can get contours milled on a particular job. This case that is being illustrated in my slide is showing a situation whereby one can mill a profile, special profile on a particular job. It doesn't matter the orientation of the profile of that job. One can get it milled in as much as the operator has the skill and the expertise to do the job. This case that is being illustrated shows a profile of a job that is not straight and is not regular, but with the use of the hand mill, one can get this profile milled by moving through the mark of the job with the ability of the table that has the capacity to move through all these axes of the job. One can get the job done. This is another very important operation that one can perform on the lathe or on the milling machine. And of course, one can equally get pockets. Pockets can be milled on a workpiece, pocket, through the use of the hand mill. One can create pockets of holes, a bigger hole that one cannot necessarily achieve with a single drill. One can make use of pocketing to create that larger hole space. So the special skill that is required is for one to be able to manipulate the table of the machine as the cutter is revolving. One manipulate the table of the machine upon which the work has been mounted in order to get the profile, and the proper feed is going to be given to the job, given to the cutter. So this is illustrated in the figure that I'm showing in my slide here. The cutter is revolving while the work is being fed according to the shape of the pocket to be made, while the depth of cut is increasing by feeding the table in the Z direction. Surface contouring is equally possible on the milling machine. There are contours, surfaces with contours. These are not regular shapes. A contour is not a regular shape, but one can get this milled on the milling machine. This is why a milling machine is very unique in this capability. A special ball nose cutter will be passing over the job, and in that case is creating the profile that is required for the job. A typical example of this is illustrated in the slide. We have this special profile on this workpiece, but the manipulation of this table that is carrying the workpiece gives the ability to get this contour machined at the end of the day. So equally of note is the mathematical calculation that is required in carrying out some milling operations. Just like the case we had in lathe machine, drilling machine, and some other machine tools. Every operation on the milling machine can have some parameters manipulated: the cutting speed, the feed rate, the machine time, just like that which we have in other machine tools. It is possible for someone to equally determine the material removal rate. At what rate is the material of the job being removed? One can get it done. All these are provided in the content material for you. By the time you look at them and walk through some of the exercises provided, you get familiar with most of the mathematical manipulations that one can have on the milling machine parameters. This is very important for you to know, but I want to give you that assurance that by the time you go for the real hands-on, the real practical in the workshop, most of these regular operations on the milling machine, you can easily perform them and you will get familiar with them, because it must be a must to know, because you cannot provide or produce some of these special parts with this different orientation and configuration without making use of the milling machine. And that is why all these operations are very important and so unique. And don't forget, at any rate, whenever any job is to be done on the milling machine, remember to take your safety very serious. No matter the kind of operation, be it the plane milling, the slab milling, the grooving, the slotting, cutting of keyways, production of gears, no matter the type of operation, let the safety be the number one priority that we give concern to or give consideration to. And I believe with that, you'll be able to be a better operator and you can perform a very good job. Until next time when we meet, bye for now.